Welcome to another series on instrument measurement. In today's videos, we will be looking at pressure transmitters, how it works, and its applications in industries. So let's dive in. So what exactly are pressure transmitters? Pressure transmitter is a device that is used to measure pressure in liquids, fluids or gases, and produces feedback to PLC. It is usually put in place to either monitor a process or alert the user before an event occurs. Let's look at a typical example. In a process that required a minimal contact time during its process, pressure transmitters are usually used. The pressure senses the pressure coming within. Once the required values have been reached, this triggers another process to happen within the loop. In this case, we are looking at valves. The valve opens and closes according to the pressure transmitter inputs. From the analogy discussed now, we can see that pressure transmitters is a critical part of a closed control loop system, because the instrument convert matters to electric signals. Again, let's look at the latter scenario, which is monitoring. Pressure transmitter monitors the level in a tanks, because there are times the value exceeds the required threshold. The pressure transmitter can be used to trigger discharge valves, and in the same vein, alert the user during pressure rise. If you want to learn more about how pressure came to be, kindly check my other videos on differential pressure transmitter. Now let's look at how pressure transmitter works. The pressures generated within the industrial machinery will react with the sensory surface of the sensors. This surface can be steel, silicon, or other materials depending upon the analyte's composition. This will create a charge known as piezoelectric effect. So what exactly is piezoelectricity? Piezoelectric effect is the charge created across certain materials when a mechanical stress is applied. This effect is the electrical signal that is generated according to the pressure applied. The effects can be current, that is 4 to 20 milliamperes, or voltage, 0 to 5 or 0 to 10 volts respectively. Pressure transmitter can be divided into three, which is according to the pressure it can measure. And example of them are gauge pressure, absolute pressure, and differential pressure transmitter, delta P. Gauge pressure. Gauge pressure is the pressure relative to atmospheric pressure. Gauge pressure is positive for pressures above atmospheric pressure, and negative for pressures below it. An absolute pressure measurement or pressure value exerted by a gas, vapor or liquid is a pressure value measured relative to a perfect reference vacuum. What is perfect vacuum pressure? Perfect vacuum pressure is defined as zero pressure. It is consequently a fixed reference for measuring the absolute pressure. Overall, absolute pressure sensors are used to measure pressure that is lower than the atmosphere. And finally, differential pressure transmitter. As the name implies, our sensors measure the difference in pressure. The high side measured the pressure within the liquid domain, while the low side measures the pressure at the top of the vessel. After measurements, the transmitter will now calculate the difference between the two pressure. If you want to learn more, kindly check my previous release for that. In summary, pressure-sensitive environments such as the gas, petrochemical, laboratory, and pharmaceutical industries often require pressure transmitters to monitor the applied force of liquids and gases as a value of either PA or PSI. This necessitates the precise integration of pressure transmitters into rapid electrical conversion equipment in our process for real-time measurements. Let's do a quick recap. We started off with what is pressure transmitter. We look at its application to industries. That is for monitoring and alerting the user. We also discuss the piezoelectric effect, which is how stress are converted to an electric signal. Finally, we ended off looking at the different types of pressure transmitters we have. Hope you have learned from us today. See you in the next module.